Hello everyone and welcome to the last part 4 of the organic solve of GSI 2022. So let us check the first question. So this is a very simple question of aromatic nucleophilic substitution. So let us draw the reaction that is going to happen. So as we can see that we have got NH3 and we have got fluorine and fluoride and chloride. So now we know that aromatic electrophilic substitution occurs at 2 or 4 position from the CN. So the CN here actually is the driving group which has got the minus I and the minus F effect, and hence we see that fluoride is present in the second position, so fluoride would be substituted. So here what happens is NH3 substitutes the fluoride to form NH2, and that is where the nucleophilic substitution takes place. So we can see this is the product of this particular reaction, and this is how it happens according to the arrow pushing mechanism. And let us see our options. So option A is the correct option for this question. Okay, so with this we move on to the next question. So this is a very interesting question that has been given. So they are asking us to find out the decreasing order of percentage of ortho/para ratio of products. So the most ortho/para ratio products would be at the first. So ortho product should be first. So let us first draw all the 1, 2, 3 and 4 compounds. So as you can understand, toluene, cumene, third butyl benzene, and fourth is ethyl benzene. So now ortho/para ratio of the product is needed here. So as you can see that the bulkiness of the alkyl group present on the ring is actually increasing in a progressive manner. So as the bulkiness increases, the percentage of ortho product would actually increase. So percentage of ortho product would decrease with the increase in bulkiness. So I'm sorry for that. And para product would increase with the increase in bulkiness. So as bulkiness of the alkyl groups, as you can understand, increases, the substitution at the second position of electrophilic aromatic reaction, which is nitration here, it increases. So ortho product increases and para product ortho product decreases and para product increases. So as bulkiness increases, ortho decreases, bulkiness increases, para increases. Okay, so now as we can see here, toluene 1 is the least bulky, so it has got the highest ortho by para ratio, because ortho is highest and para is lowest in case of toluene. Now then there is 4, which is the second least bulky, and then it is 2, which is cumene, and then it is 3. So hence you can understand, to find out the highest ortho para ratio, it should be first 1, then 4, then 2, and then 3. So this was a pretty easy question, but an interesting one, Okay, so let us go to the third question of this part. So we have been asked that which one of the following substrates does not participate in Friedel-Crafts alkylation. Okay, so now the substrate which is not participating means among which of these would not have a sp3. So for the participation in Friedel-Crafts, we need an sp3 carbon which is attached to the halogen. So as you can see, B, C and D all have sp3 carbons attached to the halogen. Only A has got sp2 carbon attached to the halogen, and hence it is not going to be acting as a Friedel-Crafts in Friedel-Crafts alkylation. So that is the answer. Okay, so now going to the next question. So see, once again we have been asked to find out the statement which is not true. So this is very important to find out in a question. So maybe the question is easy, but this not or what is given in the question should be read carefully during the time of the exam. Okay, so let us see. So we have been given this particular compound 2-chloropyridine. Now nitrogen is more electronegative than carbon, and hence for nucleophilic substitution, aromatic nucleophilic substitution, 2-chloropyridine is obviously more reactive than chlorobenzene, as you can understand. Now iodobenzene is more reactive than fluorobenzene, obviously, because carbon iodine bonds are weaker than carbon fluorine bonds in general, and hence this is more reactive because carbon iodine bond will break easier than carbon fluorine bonds if there are no other groups present. Okay, so now the third statement is 2-chloronitrobenzene is more reactive than 3-chloronitrobenzene. Okay, so let us draw the compounds. Now as you can see that nucleophilic substitution takes place, and here what happens is that the position of the chlorine where the nucleophilic substitution takes place, the nitro group can actually act via the minus M and the minus I effect, both. So also the electron withdrawing effect and also the resonating effect that it has. But 2-chloropyridine, 2-chloronitrobenzene does not have that thing. So hence here the nitro group cannot extend the conjugation. And so by elimination process, already the fourth statement is the correct answer, but let us check it out. So 3-chloropyridine actually once again gets the negative charge on the more electronegative nitrogen, and hence it is more stable at aromatic nucleophilic substitution reaction, and hence the reactivity is more. And so the statement D is incorrect, that 2-chloro is more reactive. Okay, so let us go to the next question. This is the fifth question. We have been given a sequence of reactions. So to find out for the preparation of ethyl 2,4-dinitrophenyl ether. So let us draw the reactions and find out what is happening, what is going on. So in the first step, okay, the nitration is happening. So dinitration happens. After that, BARC TIFR bromination reaction. So now the ring has already been deactivated a lot with the 2 nitro groups present. Hence, no reaction takes place. No further reaction takes place in this part question. So let us see the next question. So first chlorination is done. So yeah, okay. So then chlorine group is actually substituted in the benzene, electrophilic aromatic substitution. After that nitration is done. So okay, 2 nitro groups will be in the ring. So chlorine is not that much deactivating. After that NO8 is given. So now you can see that 2 nitro groups are present. So once again the ring is very much deactivated and nucleophilic aromatic substitution can take place. So OAT minus actually substitutes chloride as a nucleophile. So aromatic nucleophilic substitution takes place in this particular question, and we get our product, which is the ethyl 2,4-dinitrophenyl ether. So that the product happens in the second question. So already we have got our answer, but let us check the next 2 questions. So Cl2FeCl3, once again chlorination is done, then NO8 is given, the ring is not deactivated enough, so no substitution takes place. And the last question, aqueous NOH does not react. Hence the second option is the answer. Okay. So let us see the 6th question of this last part. Okay, so number of 1-2 rearrangements occurring in the following transformation. So first of all, let us draw the structure. It is quite difficult to draw. Okay, so okay, CH3 and OH, SOCl2 has been provided with pyridine. So what happens first is the OH is replaced with chloride, and this is done because the chloride is a better leaving group than the OH. After that, the chloride leaves by its own accord because the positive charge is formed, which is basically a tertiary carbocation, and that is quite stable. And after that, rearrangements start taking place. So this is the first 1-2 rearrangement that takes place. So let me draw the structure first quickly, and as you can see, so this is the first 5-membered ring that has formed, and positive charge is actually rearranged on a different carbon atom, and this is also 3-degree carbocation, so this rearrangement can take place. So okay, so now we see, and the 4-membered ring is actually going to the 5-membered ring, so that is the driving force of the reaction, of the rearrangement. So now we can see 4 such other 1-2 rearrangements can take place as the arrows indicate. So these will be subsequent reactions one by one which will take place, and after that we will get these 5 5-membered cycles, and lastly there will be a positive charge present, and once again there is a proton, and that particular proton would actually form a C double bond C to satisfy that positive charge in that particular place. So okay, so I will once again in a little bit smaller manner draw the structure. So as you can understand, it's quite difficult to draw the structure very fast, so that I can cover the whole video in a less than 15 minutes. So hence total number of rearrangements 5 1-2 rearrangements. So third option C is the answer to our question. Okay, so let's go to the next question, the 7th question, 117. As you can see that we have been given a pinacol type of substrate. So there are 2 OH, so diol is present. Now we have H plus, and so that protonates one of the alcohols. And after that, what happens is the ring migration takes place, and that particular water group actually is eliminated, and we get a carbonyl group, carbon functionality at that position, and a 5-membered ring. So once again, the reaction driving force is the formation of C double bond O, which is a very strong bond, and also a 5-membered ring from a 4-membered ring, relaxing the strain. So then LiLH has been given, which actually reduces the carbonyl group C double bond O into OH alcohol. After that, once again protonation is done, so it becomes OH2 plus, and positive charge generates after along with the ring migration, ring expansion. So once again another ring expansion takes place, and there is a carbocation formed, and the H comes in, and this is the A is our product. So we land directly at our product with our reaction. Okay, so let us go to the next question. So we have been asked to find out which intermediate is less likely to be formed. So once again, focus on the less part that has been given. Okay, so let us just see the mechanism of the whole reaction. That is what can happen. So first of all, protonation is taking place. So as you can understand, not the terminal OH but the OH present in the middle actually gets protonated. So this is because the carbocation that is formed after that is a 2-degree carbocation, whereas if the OH at the terminal was protonated, a 1-degree carbocation would have formed. So 2 degree is more stable than 1 degree. After that, a 1,2 H shift occurs. Once again, this H shift, the driving force of this H shift is because after this rearrangement, the positive charge goes from a 2-degree carbocation to a 3-degree carbocation, which is again more stable. So these are actually known as skeletal rearrangements, also called Wagner-Meerwein rearrangements. So you can check it in any standard organic book. So now as you can see that a positive charge has been generated in the carbon adjacent to OH, which is driving because it forms a C double bond O, because the OH can actually stabilize that particular carbocation, and hence we get our product. So let us see which of the intermediates we can actually see, and we can understand that less likely means the intermediate that does not form. So the first one of course forms, as we have seen, it is the 2-degree carbocation. Second one forms, which is the 3-degree. It forms after a 1,2 H shift, and the third one of course forms because the OH can actually stabilize the carbocation. But the last one that actually does not form, we do not see that particular 1-degree carbocation in the first step. Hence, that is less likely to form. So fourth option is our answer. So let us see the next question we have been asked. Neighboring group participation NGP in the following reaction. So let us draw the chair form obviously. So as we can see, this is one carbon apart. So we will be drawing it one carbon apart, and both would be in the top, at the above of the chair form. So as you can see, NGP is taking place in the first step, and chloride is actually relieved, and we can actually find out that we have got a neighboring group participation from the methoxy OCH3 into the acid chloride COCl group, and a 5-membered ring ensues, and we get a 5-membered ring with a positive charge on the oxygen of the methoxy. Now the chloride that has been given to us attacks via equatorial attack, and it actually opens up the ring. So equatorial attack takes place because the top part, that is a ring has formed, a bridge has formed, hence the top part is not accessible to chloride, and hence due to NGP the equatorial attack of Cl- takes place, and this is our product. So let us draw it in a normal hash and wedge structure to find out our option. So as you can see, the COCH3 is on the wedge and Cl is on the hash. So A is our answer. Okay, so with this we come to the last question. So this is a very easy question, as you have seen. Bromine H2O, once again a cyclic bromonium ion is formed in the first step, then H2O is present in large excess, so H2O opens up the cyclic bromonium ion, and it opens up in a regioselective manner to the more substituted carbon, and we get our answer. And as you know that here H2O is present in large excess and acts as the nucleophile, so it is the competitive nucleophile and not bromine, and hence this is our answer. So option C is our answer for this question. So with this I come to the end of our organic questions GSI 2022 chemistry paper preliminary exam solved. So thank you, practice well, and follow for more, and thank you.